Example 5 says use the first derivative test to graph the function f of x is equal to x times the square root of 2 minus x squared. Now before we jump into the first derivative test, I want to set f of x equal to 0 to solve for the x-intercepts. And if I use the zero product principle, I can set both of these things equal to 0 individually. And this is already solved for, so there is an x-intercept at the point 0, 0. And then if we solve this one, if I square both sides of the equation, then I get 2 minus x squared is equal to 0. Then I could subtract 2 on both sides. Then if I divide both sides by -1, I get x squared is equal to positive 2. And then if I take the square root of both sides, I get x is equal to plus or minus the square root of 2. So now there is an x-intercept at root 2, 0, and another one at negative root 2, 0. Okay, so we've solved for our x-intercepts. Now I'm going to erase this to make some room. Let's go ahead and find the first derivative. So f prime of x is equal to, we're going to need to use the product rule since we're multiplying two functions together. So we have x times the derivative of the second, which is going to be 1/2 2 minus x squared to the negative 1/2 power. And I need to use chain rule since there's a function inside of that, and the derivative of that is negative 2x plus the second function times the derivative of the first function, which is 1. Now it looks quite daunting, so let's see if we can't simplify that a little bit. This 2 here will cancel out with that 2. And this x and this negative x will multiply to be negative x squared. And let's convert this here. Because it's to the negative power, I'm going to stick that in the denominator and rewrite that as the square root of 2 minus x squared plus this stuff here, which is just the square root of 2 minus x squared. Okay, still not so pretty. What I want to do now is I want to find a common denominator. So I'm going to multiply this thing here by the square root of 2 minus x squared so that both of those terms will have the same denominator. If I do this, then I'll get negative x squared, and notice that these are the exact same thing. So if you square that, the square root symbol is going to disappear, and we'll get plus 2 minus x squared over the square root of 2 minus x squared. And if we simplify that, we get negative 2x squared plus 2 over the square root of 2 minus x squared. So we've gone ahead and simplified our first derivative, and now we want to set it equal to 0. And whenever you have a rational function, when you set it equal to 0, a rational function is equal to 0 when the numerator is equal to 0. So if we set this whole thing equal to 0, really we just need to solve this is equal to 0 when we're dealing with a rational function. So we want to solve the following equation in order to find our critical values. We want to solve negative 2x squared plus 2 is equal to 0. So if I subtract 2 on both sides and then divide both sides by negative 2, we get x squared is equal to 1. If I then take the square root of both sides, we get x is equal to plus or minus 1. So our critical values are 1 and negative 1. I'm now going to make my sign chart. So here is -1, here's +1, and I need to come up with my test numbers. We have to be a little bit careful with our test numbers, and that is because our domain is limited in this example, and let me show you why that is. Recall that when you're dealing with square root functions, you can't take the square root of a negative function, and so the thing under the square root here has to be greater than or equal to 0. And so we have -x squared plus 2, and that needs to be greater than or equal to 0. If you graphed this function, it's a parabola that's facing downwards, it's going to look something like this. So if you think about where that graph is positive or where it's above the x-axis, this value here is the negative square root of 2, and this value here is the positive square root of 2. So that means that our domain for this function is the negative square root of 2 to the positive square root of 2. So when we're choosing our test numbers, I cannot choose a number that is smaller than the negative square root of 2. So this is where it kind of sucks, because I can't choose an integer, because here I am cut off by the negative square root of 2, which is approximately -1.414. And on this side, I'm cut off by positive square root of 2, which is approximately 1.414. So for my test numbers, I'm going to choose 0, -1.1, and +1.1. And then I'm going to evaluate all of those using our derivative function, which I am now realizing I erased, but our derivative function was f prime of x is equal to -2x squared plus 2 over the square root of 2 minus x squared. So let's evaluate each of these. Let's plug in 0 first. I think that one's going to be a little bit easier to work with since it's an integer. So if I plug in 0, then -2x squared, that would become 0. So I'd have 0 plus 2 over the square root of 2. And that is positive, so I'm just going to put a plus sign here. And then let's do f prime of -1.1. That is going to be -1.1 squared would be positive, so it'd be -2 times something that's a little bit more than 1. So our numerator is going to be negative, and then our denominator is going to be positive, so that's going to make the whole fraction a negative. So this here is going to be negative, and then f prime of +1.1 is going to give us the same thing. It's going to be negative, so I'm going to put a negative here. So that means that it's decreasing, then increasing, then decreasing again. So -1 is a relative minimum, and +1, there is a relative maximum there. So if I graphed our function, there's a lot of work for this problem, but it'll be worth it when we're done. So here's negative square root of 2. Here's -1. Here's +1. And here's positive square root of 2. Our graph is going to look so we know that there's an x-intercept there, an x-intercept there, and an x-intercept there, and we know that there is a relative min there and a relative max here. So our function is going to look something like that. And we didn't evaluate these to find the critical points. I will let you do that, but your critical points are 1, 1 and -1, -1. So please verify that. So this is -1 and this is +1. So there is the sketch of our graph. Please draw it better than I do because my drawing skills are quite poor. And that is example 5.